question is about differentiation. The equation of a curve is y equals e to the sine x over cos squared x. Find dy dx of, and hence find the x coordinates of the stationary point. So the stationary points of the curve means the y prime equals 0. So stationary points means y prime or dy dx equals 0. So we need to find the y prime, and here we use the product rule, or the from the MF19 we have the product rule u times v. So the derivative of u times v, we have to identify the u and the v. So here the u is e to the sine x, the v is cos squared x. So the formula is u prime. So this is the derivative of e to the sine x. The derivative of e to the sine x is exactly the same e to the sine x times the derivative of the power. The derivative of sine x is cos x. So this is the u prime. This is v, just rewrite, minus v prime. This is v prime. So the derivative of the denominator, we use the power rule. We bring the power down, so we have 2 times cos. The power becomes n minus 1, so 2 minus 1. So 2 times cos x, the power is now 1, times the derivative of the base, so the derivative of cos. So the derivative of cos is minus sine. So this is the v prime times u. U prime v minus v prime u all over v squared. This is the v squared. Okay, so we are solving this y prime equals 0. So when we are solving a fraction equals 0, we can just solve the numerator equals 0, or we multiply both sides by the denominator. So when we are solving something equals 0, we have to make it a multiplication, so not a subtraction like this, which means we have to factor out things so you get a multiplication. So here we factor out e to the sine x. So from this first term we still have cos cubed, and from this term, if we factor out e to the sine x, we still have this part here. So we still have minus times minus is plus, so we have plus 2 sine cos. Right now we have a multiplication, something times something equals 0, and yeah, we can solve this. But if you look at inside the brackets, we can still factor out cos x. So we factor out cos x, we have cos squared plus 2 sine. So we have 3 factors: e to the sine x, cos x, and cos squared x plus 2 sine x. Now we can't really solve this right away because something is in cos, something is in sine. So we have to make it all in cos or all in sine. Now we can't really change this into cos easily, but we can replace this with 1 minus sine squared using the MF19 Pythagorean formula. Cos squared plus sine squared equals 1. So we use 1 minus sine squared instead. Everything is in sine. This is just a simple quadratic. Now we can solve everything. So from the first factor equals 0, well, you can do ln both sides. You cancel out on the left, but on the right, if you use your calculator, you will get 0. This is just impossible, so it's rejected. Now from the second factor cos x equals 0 means this is from 0 to 2 pi. So the x domain is from 0 to 2 pi. So if you just remember the shape of the cos x graph, the cos x is 0 when the x is 90 degrees and 270 degrees. Or you can just use the quadrant rule here. The value of cos is 0 when it's again 90 degrees and 270 degrees. So in radians we have pi over 2, 3 pi over 2. Okay, now in case you are wondering why this is rejected, because if cos x is 0, if you look at the y prime again here, if cos x is 0, we're going to divide by 0, which is undefined. Or you can cancel out here, so you can divide by cos, divide by cos, divide by cos. So actually there will be no cos x factor in the numerator if you cancel out. So there is just no possible solution from cos x equals 0. And now from the third factor equals 0, so you can just use the quadratic formula. Here we have minus sine squared plus 2 sine plus 1, or you can multiply both sides by minus, and you can identify the a, the b, and the c, plug into the quadratic formula, minus b plus minus square root b squared minus 4ac all over 2a, and you have two solutions from the quadratics, 1 minus root 2, 1 plus 2 root 2. Now if you try and use 1 plus root 2, inverse sine 1 plus root 2, you will get again an error because the value of sine cannot be bigger than 1. So the only possibility is from 1 minus root 2. Now to find the base angle, so the first quadrant angle, we have to use inverse sine the positive value. So instead of 1 minus root 2, we have to do, because obviously this is something negative, we have to use something positive, so we use minus this value, so minus 1 plus root 2. This way we get the angle in the first quadrant. We don't get the negative angle but the positive first quadrant angle. So since we are looking for sine x value negative, because sine x equals something negative, this is something negative, that means we have to use the second quadrant, or the third and the fourth quadrant, because sine is negative in the third and in the fourth quadrant. In this domain we can use the third and the fourth quadrant. To find the third quadrant, we do pi plus base angle, and fourth quadrant 2 pi minus base angle. So we get this from pi plus this inverse sine, and we get this value from 2 pi minus this base angle. Alright, so we have only two solutions, and question is just to find the x coordinates, no need to find the y coordinates, so we are done here. Alright, I'll see you again next time.